Okay. Good morning, ladies and gentlemen. My name is Erkin. I'm an assistant professor from Delft University of Technology, and thank you very much for inviting me here and for the nice introduction. I'm very happy, not because this is my first time in Israel, but the agenda today, the talks in the first and second sessions were amazingly related to what I was working for the last decade, and I hopefully explain my research about privacy enhancing technologies today to you. Before starting, I need to tell you a few things. I need to do some marketing, because when I told my head of the section saying that I'm going to Israel, he said I need to do some commercials. Sorry for that. But before starting that, I need to know my audience. Who knows about cryptography? Who works about that, or who takes courses on that? Okay, I'm good. I'm not going to explain anything mathematical, but hopefully I will try to show you that we have some solutions for privacy protection. My talk will be as follows: some marketing about my university group and myself, GDPR, amazing talks in the morning we had, and yesterday a plenary session. Then my main topic will be processing encrypted data for privacy protection. And hopefully I will conclude with some research directions. This is Delft University of Technology. It is the oldest technical university in the Netherlands. We are located in Delft itself. It's a city between Rotterdam and The Hague. So we are really close to the very big organizations like International Court of Justice, Europol, Interpol. They are only 5-10 kilometers away from us. And even though the Netherlands is a very small country, it is actually very cybersecurity driven country. If you haven't been to Amsterdam for smoking pot, this is the map. And of course, Delft, I'm very proud, is one of the top universities in general rankings in technical domain and general ranking as well. And of course, electrical engineering, mathematics, and computer science hosts the group Cybersecurity. It's a big university with history and very successful people. And what was discussed in the morning session, they saying that privacy is a multidisciplinary research. Not only computer scientists can solve our problems today, but you need ethical people who knows about ethics, economists, right? Legal people, and of course the social impact. Because of that, 2 years ago, the Netherlands introduced this Cybersecurity Specialization program among the 3 technical universities. We only have 4. 3 universities came together to come up with a cybersecurity specialization in which students had to take 1/3 of the courses in those aspects: ethical, economical, political, legal aspects. So we want to educate people, computer scientists, knowing a third language actually, to talk about ethics, to talk about economy and privacy as well. In a nutshell, my research is about privacy enhancing technologies, but it is computational privacy. I don't know much about law or regulations or ethical issues. What I believe, I'm a little bit, I have some trust issues. I want to protect my privacy. That's it. I don't care about what law says or so. As a researcher, I say my data is very sensitive. It should be protected no matter what. And I want to do that in a very efficient way. GDPR is effective. I'm so happy. The first 2 days of the GDPR being effective, I got like 25 emails from different corporations saying that, can we use your email address? We need your consent. But I had no idea that I enlisted myself to those distribution lists. It's crazy. And I didn't know that. Well, GDPR has very highlights we discussed in the morning with beautiful presentations today. There are some highlights. First of all, it is about European Union citizens, but if you do business about European Union citizens at all, no matter which country, you're obliged. And it's really good. I'm super happy about that. But there are so many problems. I mean, how to implement those things, how to delete data itself is a big problem. But on top of that, if you want to come up with a new system and new service for your people and privacy in your mind, and you want to comply with the GDPR, what are the possibilities if you are dealing with data? Anonymization techniques, we know that they are not very safe. You can de-anonymize easily. Encryption is fine, but what if the encryption is not sufficient? If an internal employee leaks this data, if it's not properly encrypted? There are so many issues, but there's one thing that we have been working in the field for decades, at least 3 decades, which is computational privacy. For those who knows about cryptography, multi-party computation. And let me start with my research. Processing encrypted data for privacy. Assume that at the airport, Alice has a camera and trying to detect criminals. Okay? She has a camera, and her face detection mechanisms are very efficient, and she wants to see if you are a criminal or not. Yeah? He doesn't look like a criminal. And Bob has the database of criminals. It is the authority. What happens right now is you detect the face, you send this face image to the authorities, Bob in this case. Bob does some signal processing, face recognition, and returns the result back to Alice. It's fine. What is the problem? Since we don't have time, I will skip the interaction. The problem is Bob has so much power. Not only he has the criminal database, but he also knows the location of Alice and the input to the system. In this case, this gentleman's beautiful face. This enables Bob actually to identify and track people in their network. And imagine that in big cities like Amsterdam, London, Paris, on every street, major street, there are cameras. It gives the authorities to track, identify anyone. But it's not only the authority. Maybe we trust them fully, no matter what, but we know that they can be hacked. Their systems can be hacked. Their systems can be breached. So anyone breaching their systems can monitor what is happening in the whole city. So this is not good. So what is the proposal? This is the solution part for privacy. If the input is very sensitive, why don't we just encrypt it? Encrypt it in such a way that the authorities cannot decrypt without the decryption key, but still process them for the purpose, but for only defined purpose. The purpose is detection of a criminal or not. The authority cannot do anything else. So in this model, Alice encrypts data using a specific encryption scheme, sends it to the service provider. Service provider works in dark. Doesn't have access to the content, but processes data according to the protocol described, and the result is, again, unknown to him. The result is sent back to Alice. Alice uses her secret key to decrypt the message and says, okay, this is a criminal, then let's move to the second step, or no, this person is not a criminal, do nothing. If this system works, and it works, it is good. We protect the sensitive input from the authorities. We also protect the algorithm from Alice. At the same time, we achieve the service. So this is really good. So this is what we call processing data under encryption using the primitives of cryptography. Everybody wins. If you look at the technical details, this is the only one with the references. The building blocks of such a system we do have since 1982. But they were expensive. They were really expensive to realize. It was not practical. We have homomorphic encryption schemes, partially homomorphic, somewhat homomorphic, or fully homomorphic, and they are getting better and better. We have secret sharing mechanisms, or Shamir secret sharing mechanisms. We have garbage circuits. So you can design any function with secret input in a very secure way. And they are provably secure. You can show how much information you leak or you don't leak per partner. Well, challenge was for the last 3-4 decades, it was the efficiency. Those systems, those constructions are expensive. But the most important challenge, if I go back again, was the business model. We have solutions, we have protocols, but for the service provider, there's no motive to deploy the system. What I'm showing here in this picture is a generic system for any service you can think of. Speech recognition, face recognition, handwriting, data mining, machine learning. We always have some kind of a algorithm on the server side, a database maybe, and the input is from the user's customers and it's processed by the service provider. So this system can be generalized to many, many services you know today. But there's no business model for the companies because they don't have raw data, which they really, really like. But this can be a solution for our problems. Well, the system works as we know it in normal plain text domain. This is a generic system for eigenface face recognition system. You represent image as a vector of numbers. You deploy some kind of projection to come out with a feature vector, and all those feature vectors are compared with the existing ones in the database. But when you have the encrypted input, all those operations will be done under encryption. And as you can see in the gray area, the database owner, Bob, doesn't have access to raw data. What is happening? Everything is under encryption. It is super nice in terms of protecting privacy, and we know how to translate your algorithms or any algorithm into encrypted domain. We have operations either linear or nonlinear. We have tools, and we can even combine different things together to come up with really efficient systems. Just as an example, this is a work from 2009, and this was the really breakthrough for this research. In a very powerful computer of that time, we managed to run this system with 400 images, very tiny little pictures, 92 by 112 pixels, and it took like 40 seconds to find a match. A person is in the database or not. 40 seconds is a long time, given that the database is very small and the pictures are very small, but that was a big, big success then because we showed that this idea works. We can protect sensitive information and the system functions, and it is reasonable. Not practical, but it's not bad. Well, just because of this talk, I assigned a couple of my students. I said, okay, after almost 10 years, where are we? The hardware significantly progressed, right? We have smartphones, very powerful chips and so on. And well, let's try to do the same thing again. And we did something really nice. This is a video of my students implementing this with a Samsung mobile phone. And as you can see, the progress in 10 years is significant. Once we were doing this expensive computation as server with multi-cores, and now we can even do that with a smartphone. We are there. And to be honest, this is an implementation by students, so there's no optimization or so. And I believe this, the real implementation, services based on processing encrypted data will be much more efficient. Well, of course, I wanted them to show some dramatical effects in case of malicious behavior or so on. But indeed, with this mobile phone, it takes only 20 seconds, which is most of the time the computation by the server side. What is going to happen? After 10 years, what is happening? We have significant progress, but it was not taken up by the industry, right? Because they want to have raw data, they don't like to have these expensive operations on the encrypted data, but we have shown for the last 10 years that this idea can be applicable to many, many domains, including this genomic privacy applications like 23andMe, it was mentioned in the morning. You can just upload your encrypted genomic data, it can be processed under encryption, you can get your result and everybody will be happy. You can design encrypted privacy-preserving versions of Netflix, or you can design eBay or Amazon where the systems don't know what you are searching for. All those things are possible, and we also implemented the secure matching of Dutch car license plate for the authorities in the Netherlands. So when you're speeding, the picture is taken, and under encryption, the plate is recognized. If you are not speeding, all those pictures are kept encrypted. So it's beautiful. And my kind of last slide, what I want to tell you here is that with GDPR, people are talking about a lot of issues, a lot of problems, right? How are we going to do this? How are we going to protect this? Privacy by design principles, can we deploy them? And most of the time, it is the driving force to convince business owners, service providers to deploy these techniques. With this talk, I just want to tell you that as techie people, computer scientists, we have ways to protect sensitive data. It is just expensive, and to make them more practical, we need a little bit more research, but I'm very optimistic that computational privacy will really significantly improve the privacy of the citizens all around the world. So with this, I would like to conclude. Thank you very much for your attention.